In this video, we're going to do a couple practice problems relating to the fundamental theorem of calculus part 2. The first one says, write an expression for f of x with the properties that the derivative is sine of x over x. That is, we want to find an antiderivative with the property that f of 1 is equal to 5. We're going to use this to solve for c at the end. That's an initial value. So the second part of the fundamental theorem of calculus says that the integral from any constant to x of sine of t over t dt is an antiderivative of sine of x over x. So if I want to find the set of all antiderivatives, I can write one antiderivative plus a constant c. So that's going to represent all antiderivatives, and I want to find one using the property that f of 1 equals 5. So this is going to be equal to my function f of x. So if I want to find f of 1, sine of t over t dt plus c, I'm going to set that equal to 5. So sine of 1, plugging in for x, will give me 5. So let's do this integral here. The integral says that the area under the curve from 1 to 1 of sine of t over t is going to be 0. We have no interval that we're looking for. It doesn't matter what sine of t over t looks like. The integral from 1 to 1 is just 0 area. Then we have plus c equals 5. So here c equals 5. So an expression for our function will be the integral from 1 to x sine of t over t dt plus 5. So actually finding that antiderivative sine of x over x is difficult, and we're not going to do it in this course. We're not even going to be able to do it in Calc 2 as well. There's not a very nice way of writing that down. So this might be the only real nice way of writing that down, this function. All right, last one is a very simple problem. This is kind of a classic problem for FTC Part 2, and there's really not much to do. What is the derivative of the integral 1.5 to x natural log of t squared plus 1? This is really just going to be natural log of x squared plus 1. You replace the t with an x. And why does that work? It's because we're taking the derivative of an antiderivative. And the second part of the fundamental theorem of calculus says that the thing inside the derivative there is an antiderivative of natural log of x squared plus 1. So this expression is an antiderivative of natural log of x squared plus 1. So if I take the derivative of that, I should just get the original function back. And that's all we're doing for the second part of the fundamental theorem of calculus. It's much more important we understand why it's there than we know how to do practice problems, but there's a few practice problems that we can do.